Hey, what's up, fellow YouTubers? So today I wanted to make a video. I think I saw a question come up on, I believe it was Cora, on how to create an algorithm for calculating the day of the week given the calendar date. So video is kind of long, but if you stick around, you'll see how I code and how I run into issues and bugs and different things, and how I test everything and how I solve the problem. It's kind of long. If you stick around, you'll get to watch me code. It may be too long for some of your tastes, but if you stick around, you can see what I do. If you don't want to stick around that long, you can always skip down to the description and then just see the code or jump around the video. But I decided to keep this video long. Let me know if you like videos long like this, or if you like them shorter. I can always edit and cut and be perfect, right? But we don't live in a perfect world. The real story is that in programming, you're going to run into issues and you're going to run into bugs, and you're going to have things that you're going to wonder why they work or why they don't work. And so this is one of those situations where ran into some issues, was trying to figure them out, question some things and work through them. In some cases, I was tinkering. Just let me know. Hope you enjoy it. Okay, so let's get started with this calculating a day of the week. See how we would approach it. So one thing about it is that we probably want to create some files where we create that, right? So if we think of an interface, we got to think of what we want. So let me add an H file. Let's add the H file right here. Let's add a CPP file. And all we want, before we write any of the code, let's go ahead and write our tests. And as some of you know, I like to write my tests very simply, like something like this. So let's say that we have a test. And usually what I do is I start with something like, just say foo, because I don't know what I want to test. So I'll say something like foo. But before I even do that, let's just call it, let's create a test function. Let's make it void. And we'll call it test. And we'll tell it what we expect. Expected and actual. And we'll have a name for the test, which we call that. And for that, we need to bring in string. Bring in the string library, and we'll also bring in, we'll already have that. I like to use std. Some say it's bad practice. I just don't like to type std_endo and all that kind of stuff. So I just like to bring it in. That way I don't have to qualify everything. Now our simple test is just going to say, this is our test utility expected, and I did a typo here. And to do that, and I can just copy and paste it. And we'll say if expected equals actual, We'll say cout test, and we'll give it the test name. And we'll say that it passed. If it doesn't, we can say something like test name. We'll say that it failed. And this is a really easy way to test your code. It's a poor man's testing approach, right? So now we can say test failed, and we'll say ... expected, and we can say expected, and we can pass it to expected. Oops, I didn't mean to do that. Put exception there, expected. But was, and we'll say, we'll put the actual here. And another thing I like to do is count my tests. So what I'm going to have to do is declare something that updates my test count. So I'm just going to pass it additionally. Test count. Another thing about test count is that we probably need to, instead of doing that, why don't we just return true or false? So we'll make this a Boolean, and instead of passing the test count, that's one way of doing it, but then I'd have to capture it every time. Now, I don't want to do that either. How about if we, it's an interesting problem to have. What should I do? I don't want to create a global, but the thing is that I have to capture what passed and what failed. So what I can do here is I can have a failed count and passed count, like that. And let's separate this a little bit so we can see it better. So we'll have to do the same thing for the other things, but one thing about this is that we want to be able to work with other types, not just integers. So let's make it a template, and we'll make it where instead of n, we'll make it t, and those have to change. Failed count, and by default we can say that it's no pointer, and let's push these down, and by default the other one will also be no pointer. And so now we need to make sure that we follow this same signature down here. And, you know, sometimes I forget how to declare these, because it's like the declaration adds it, but then it doesn't like it down here. Let me see what it says. Query redefinition of default arguments. So I think this is kind of weird. Okay. It's kind of weird in C++ that you don't do it. You don't do it in both places, but okay, we'll roll with it. So now if it passed, one thing about this is we want to say, the thing is, like I said, if we don't pass anything here, there's going to be a problem. So now we have to check to see if failed count not equal no pointer. Actually, this is pass count not equal no pointer. Then we just want to say pass count plus plus, and we can do the same thing down here for failed count. If failed count not equal no pointer, we'll say that failed count plus plus. Like that. Doesn't seem to like that very much. And I think it's because I have to do it like this. And the first thing we'll do is test to see if this actually works. So let's see if our little test utility works. And we're gonna just do a simple, we call test, and we'll pass 0 and 1. And we'll give it a test name. Test the tester. And we'll pass it and failed count. That's how do I have it? It's failed count. Yeah, failed count and pass count. And we have to declare these. Let's get rid of the hello world. And let's go ahead and do the pass count. Check one thing. The pass count is 0 as well. And let's see if this works. It should fail. Test, the tester failed, expected 0, 1, what was 1. One thing that I like to do though, as well, is that I like to put, for the expected and the actual, I like to put quotes around it. Sometimes it's misleading because the problem may be that it's not a string, right? So one thing we could do, as opposed to, we could put a this instead around it, because I like to see leading and trailing spaces. And so maybe that's better. Let's run it again and see. Okay, expected 0, but was 1. Okay, that's good. That way, if there's any trailing spaces, and here's what I mean by that. Let's say that I was testing a string. And if I was testing a string, and this was A, and this was A, we should be able to see that it failed because of trailing or leading spaces. So let's test that one out. And you can see here, expected A space, expected space A, which is not the same thing. Okay, and that's the reason that I like to put something around that so I can see it. Now that we know that our testing works with integers and strings, it should work with floats and booleans and all of that. So now we want to create our actual, begin coding our actual test. Now, the thing is, we need to, what we're attempting to do in this case is have a function that calculates the day of the week based on the date today. And there's different ways you can do it. One way that I would choose is to create a known date and then work my way forward or backwards from there. Okay, so for example, I will create a test that when I pass, I'm going to say the day of week is going to be an integer, right? 0 for Sunday or 1 for Sunday, and then 7 for Saturday, starting on Sunday, ending on Saturday. So I'm going to say day of week equals get day of week. And I'm going to pass it a date. How I pass it a date is I'm going to pass it by year, month. Oh, it's not going to be that way. I'm going to pass it the year, and let's hard code it. So it's going to be the year, which will be 2021. Today, we'll put today's date. So today's the 18th, and we'll go to, actually, we're going to do the month, which is 11. It's November 18. And we are going to say that we expect this test for the day of the week. Since today is Saturday, we are going to say that we expect 7. And actually, how do other things calculate the day of the week? What is the day of week in Java, for example? Day of week as int in Java. Let's try to stick with something that already exists out there. Let's see what it does. Day of week. What values? So it has enums. So Friday is 5. That means that Saturday would be 6. And Saturday would be 6. And Sunday would be 7. So let's go with that. Okay. So we expect today then to be 6. And that's the expected, and the actual is going to be the day of week. And then we're going to call it, we'll call it today. We'll call it, we'll call this one date of, date of code. Okay, and then we'll pass it the failed count, and we'll pass it the pass count. As you can see, we have a problem because we haven't defined day of week. So let's define the day of week. So let's go into our date utility and we'll create a day of week. So it's going to return an integer, get day of week, and we'll pass it the year, the month, and the day. And it has to turn around and give us something. Oh, well, this is just our H file. So let's take this and let's copy it over to our CBP file. And let's put it here. And for now, let's return 0, right? And we'll save it and run it. So the other thing that we have to do in our main is include that. Include date util. One thing about H files is we always have to do this. And I know Visual Studio doesn't do it, but it's good practice. I do it even there. So I just call it date util H, and then we'll define it. And we'll finish it off with end if. And so we have our get day of week. This one also has to include yeah, it's just good practice. Date util, because there may be other functions that we write in there that we need. Okay, so now our main should compile. This thing's still struggling. Let's see, why is it struggling? No matching function called test. Test name. Oh, the reason why is because we had to pass these by reference, because we want to modify them in that function. So let's go ahead and run this. Okay, test date, the date of code failed. Expected 6, but was 0. So now we have something to fix. So according to Robert Martin, we should only write enough code to make it pass. It expects 6. Let's return 6. Let's run it again, and it should pass. So now let's write some more tests. So now let's go back into the past. So now we write another, we'll say day of week equals get day of week. We'll go back into the past. We'll still go 2021. We'll go something like 7 or 6 days prior. Let's see, if we go -6 minus 6 is 0. So it should give us a 7. So we go -6 days. It should give us, so let's see, if we go 7 days ago, we're on the 11th. And the 11th would have been another that, so we don't want the 11th. We want it to be, let's go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let's go the 12th, which should give us a 7. So now in this case, we expect this thing to be the expected is 7, and this is date of code -6. Okay. And so in this case, this will fail. And it failed, expected 7, but was 6. So the thing we do is we got to start working on getting our code right. So one thing is, how do we begin figuring out our date of week? Well, one thing is we probably need another function to calculate it from a linear date, right? So we want to take like a date, and a lot of times when you work with dates, you want to figure out from a certain point to a certain point. So what if we took the calendar and we looked at the calendar and said, So let's take a look at the date. Let's take, for example, let's look at a calendar. So let's say that we wanted to start from 1950 and we want to start, yeah, it's perfect. Look at that. It's Sundays on the 1st. So 1/1/1950 is a Sunday. So if we go back to our code, we know that 1/1/1950 is a Sunday, okay? So now we're gonna make that our day 1. So everything is going to begin from there for us. So in order to calculate a day, we'll have to calculate a day from 1/1/1950. So we're going to create a function called, let's call it get day from Genesis. We'll call it Genesis, right? I would like it better. Get day from Genesis, and we'll give it a year, month, and day, right? We'll give it a month, year, month, and day. So now, with this in mind, when we figure out the day, we need to calculate how many years from 1950. So we'll say years from 1950 is going to be equal to the year minus 1950. Okay. So we have the year, for example, 2021. So we have the year 2021. That'll be 71, right? Which will get us all the way up to that year, right? 71. And then from there, one of the things that we have to figure out is, and this is kind of known, so one of the things that is known is that we can figure out how many leap years. We can calculate the number of leap years by just looping through. So we can count the leap years in between. We can set it to a hard-coded number because we know how many leap years are in between, or we can count them. So for so 1950 itself is not a leap year, right? I don't think it is. And it would matter. So for int, year equals 1950, year less than, and this is, we'll call this, we'll just call it y because we already have year defined. So we'll say y less than year. And we'll say y plus plus, and we'll say, we'll calculate if it's a leap year. If year mod 4 equals if year mod 4 equals 0, we'll count leap years, right? But it's not that simple because we also have to know if year mod 100 is not a leap year, and year mod 100 equals 0. And year mod, if it's divisible by 100, it has to be divisible by 400 also, like the year 2000. Okay. Then it's leap year. Then we could say that it's a leap year. Plus, plus. Right? If we could say else if year else if it's not if it's divisible by 100, if it's not divisible by 100, so let's think about this. If it's divisible by 100 and 400, it's else if year divisible by 100, not a leap year, right? We don't do anything. And instead of doing that, we can actually say if year divisible by 100 not equal 0, or year is divisible by both 100 and 400, then it's leap year. If it otherwise, it's not leap year. So there. So now we got our leap years. One thing about it, one additional thing about it is that we have to account for the fact that the current year we counted it as a leap year, and if the current day, the current year is a leap year, so if year, and now we're getting into, we're duplicating code, so we actually need to have something that just calculates the leap year. So we'll create a Boolean is leap year, and we'll pass it the year. Okay, and is leap year, and we'll say that since we have all this, we can take all of this out, and we can say if year mod 4 equals 0, leap year. But we don't want to count the leap year. In this case, we return true. And otherwise, we return false. It's not a leap year. If is leap year, we pass it the year. Leap year plus plus. So leap years. So we've counted all the leap years. One thing is that we don't want to add extra days, right? Because what's going to happen, and I'm wondering if it matters, if it actually matters. Well, it does matter. Does it matter? I wonder, does it? Oh yeah, it's because we have to calculate the number of days from the years. So there we go. So now in this case, there's a problem though, because if we say there's 71 years in between here and we're going to multiply them, we actually have to take and subtract one of the years here. There. And if the year is leap year here, the current year is leap year, and day is greater than, and month is greater than 2, or month equals 2 and day, I guess that it would be day equals 29. If month greater than 2, we gotta add an extra day. Then we can say that leap years, we add an extra day. Because in reality, what we're adding is not the leap years, we're actually adding the leap year days, right? So leap year days. We're adding the leap year days. So now we have to figure out, based on that, the days from Genesis equals the years from 1950 times 365 plus the leap year days but we're missing the last year. So in order to calculate the last day, we're going to say, we can use a switch statement here, and then we'll do it like this. Switch, we'll say month, and we'll say case 12 days from Genesis we'll add the dates for November. Case 11, we'll add the dates from, we'll add the dates for October, which are 31. At October, and so on. In case if we're in October, we'll add the dates from we'll add the dates for September. We could just probably copy this. Save us a lot of typing. So we'll go 9. It'll be September, August. This has 31 days. If it's August, it'll have August, and then we're adding the dates for July, which is also 31. And if we're in July, we'll add the dates for June, which is 30th. And if we're in June, we'll add the dates for May, which are 31. And if it's May, we'll add the dates for April. And if we are in April, we add the days for March, which are 31. And if we are in March, we'll add the days for February, which are 28. And if we are in February, we add the dates for January. And if we're in January, we don't add anything because we wouldn't add the dates for December. Here's the thing though. One thing about it is that we also have to add the days. It's not giving me intelligence. Days from Genesis plus equal the day. One thing that I did, I was calculating that extra day for February. One of the problems is that if we're on February 29th, I've added that extra day, right? So we need to add that extra day only if we're not on this date on 29. We don't need to add it because if we're in February, if it's 2, we don't need to add that extra day. And the reason being is that we're going to add whatever day is on there. So now this days from Genesis gives us a sequential number. Get days from Genesis, which is going to give us the days from Genesis, and we'll return that. Okay. And now with that, we can do something. So this right here, I think would justify a test. But if we can test this like this, then we don't have to worry about that so much. So now one thing we have to do is say, get days from Genesis. And days from Genesis. And get dates from Genesis And we'll pass it to year, month, and day. I think I must have typoed something. So now the only thing we have to do is return days from Genesis, right? Because we know if it's 1, it'll be 1, 2, 3, 4, 5. It'll give us, but if it's the 7th day, right? If it's the 7th day, will give us 0, 1, 2, 3, 4, 5. And then it'll give us 6. But when we get to 7, it'll give us 0, right? So days from Genesis, mod 7. If it's 1, it'll give us 1, which is not what we want, because it, like the 2nd day from Genesis, it'll be 1. So I think we had to add 1 to it. Yeah. So it'll give us 1. So it'll give us like 1. Let's see, days from Genesis plus 1. So for example, if it's 1 day from Genesis, it'll give us 1, which is really 2. And then 3, 4, 5, 6, 7. When on the 7th day, it gives us 0 plus 1. If it's, let's see, if we're 1 day from Genesis, so it'll give us 2, 3, 4, 5. On the 7th day, it'll give us 0. So how can we fix that problem? Let's see. If the day is one from Genesis, which will be 1. So we're 1 day away from Genesis, and we divide it by 7. I think it's the other way around. I think we have to say, if we're 1 mod 7, it's going to give us 1, but we have to add 1 to it. So it'll be 2, 3 days from Genesis, which will be the 4th day. It goes 3 plus 1. But what if we're 7 days away from Genesis? Mod 7 will give us 0. Seven. How do we get a 7 out of the deal? If we're on the 7 days, well, actually, it's right, because 6 days from Genesis is 7. 7 days from it is 0, so it'll give us 1. So yeah, I think this is right. So let's test it out. So get day of week. So now let's run it. Day is 6, expected 7, what was 6? The date of code minus 6 failed. Expected 7, but was 6. Why is that? Our test could be wrong too. If we say that 11, 12, wait a minute, 11, 12 is 11, 12 is 7. Oh, you know what we're doing wrong? When I look at the calendar, that's what's wrong with it, because that's actually where's our calendar? Our calendar, 1 is Sunday. It should be Monday. So it's not exact. It's actually that. So we got to take and subtract 1 from our day. I think it'll be fine if we subtract 1. Actually, it works out perfect, because at that point, we don't have to add the 1. But we still have to, see, we don't want it to be 0. We don't want it ever to be 0. So days from Genesis. So we got to think about this a little bit. Days from Genesis. Days from Genesis. So that's, so our Genesis should actually be 2. So let's see, days from Genesis is, we're off by 1. So we got to add 1 for it. We got to actually add 2, I think. Now that's a problem, though. Because we run into a different problem. If we add 2 to it, the lowest days we can have is, if it's 0, it's going to be 2. How can we solve that problem? Let's go look at our calendar again. We want this days from Genesis. This is our 1. It's actually, Genesis is January 2nd, 1950. If we're 1 from Genesis, we want it to be, if it's 1 from Genesis, we want this date to be 2. So 1, we want it to be 2. We're off by 1. This should be so simple when you think about it, but it kind of, sometimes the toughest problems to solve are off by 1 errors. And we're off by 1. If we add, like in the case of where it lands on a certain date, it's off by 1. So if it's 1 day from Genesis, could the problem be if days from Genesis is 7 plus 1, it gives us 6, but we need it to be 7. If we add 2 to it, it would give us 7. But how about if should the days from Genesis be we're 1 day from Genesis. We're 1 day from Genesis. 1 day from Genesis. Should we add 1 and then divide? Let's see if we're 1 day away from Genesis. It would probably make more sense to add 1. Should it be days from Genesis minus 1? I think it's in our calculation. It could probably be going different places, but since we're calculating the days from Genesis, we probably should subtract 1 because we calculated 365 days. So we probably got to take one day from Genesis. Let's see. Oh, that got us in a worse position. Actually, we might actually need to add 1 here. Let's see. And we'll test it out. It's going to give us different ones. So they passed. Okay, that satisfies our condition. That doesn't mean this is correct. We got to test out some other dates. So let's test out something else. And since we're in the 1950 calendar, let's test another date. Let's test 8/20 and 8/23. Let's test some of these dates. 8/20, 8/23, and 8/26. Let's test those out. Okay. And we expect the 20th to be 7. Okay. It's gonna be 1950. 8/20. Let's test that out. Oh, interesting. You got -5. Do we have them in that order? Year, month, day. Year, month, day. It's an interesting problem. Okay. Get day of week, 1950, 8/20. Day of week, get day of week. We got a negative number. That's an interesting 7, and day of week came out negative. How do we even get a negative day of week? Let's take a look at it. How can we have negative day of week? Oh, on that year, because we have year minus 1950 minus 1. So in this case, the year is 1950 minus 1950, which would give us year minus year is 0 minus 1. It gives us a negative 1. So we shouldn't do, I think we need to get rid of this minus 1. Let's try it again. And now we have a whole bunch of failures, right? So we have the date code failed, expect 6, go with 7, and so on. So years, we can't count the leap days, okay? Because that was only for counting the leap days. So we say if it's leap day, days from Genesis. And here's the thing, years from 1950, it's gonna be 0 times 365. So that should be okay. Plus leap year days, days from Genesis. That should have been okay. So days from Genesis, years from 1950, which is 0, that's fine. And we got times 365 days, which is gonna give us 0, plus the leap year days, which is none, 0. And now we go through the months, and we say if it's December, we add 30 days. If it's November, we add that, but it was August. So we add the dates for July, 31. We add the days for June. We add the days for May. We add the days for April. We add the days for March. We add the days for February, and we add the days for January, which should give us a total of all these days. So whatever those days were, actually it was August. So we have 1, 2, 3, we have 8 months times 30, which would be 240 days, plus 41, 42, 43, 44. 244 minus 2 here, 244, 242 days. Let's see how far off we're off. We're off by 1 again. So this time, instead of it being 1, instead of being 7, it was 1. And this one is lower. This is 1 day greater, this is 1 day greater, but this one is interesting because this is like way off. And I think all our problems are right in here. Oh, did we not add our leap year days? Yeah, we did add our leap year days. That's probably what this thing is, adding the wrong leap year days. one thing about it is that we're not including the last year, but that's okay. This is what's interesting though. Probably would help to put something in here. Because we're adding one extra day. If we take that off, let's see. So we got those passing, but then August 20, 1950 failed, expected 7, but was 2. Oh, wait a minute. Is that right? Hold on a second. August 20th should be 7. Why is it 2? If we added all those days. You know what? I think that days from Genesis is off right here because we shouldn't add days from Genesis should have one less than but it doesn't matter because we're not even calculating that. But I think this should actually have -1 day. Either one. I wonder if this is supposed to be -1 here. Oh, that's totally off. I'm tinkering now. I didn't mean to tinker on this. This has to be a more systemic approach, but this is what's boggling me here is that we have the 6, but we have this expected 7, but was 2. So if we walk it down, let's put a CL statement and see what this says. I'll just put a number by it. Uh, $25,000. There's no way. $25,000. There's no way that many days and 70 times 300. guess so. No, that's not right. Even in 2020, there's no way that it could be test date. So we start off with 0 here. Let's do this. See what that is. $232 days. So there's 90 days, 120 days, 151, 181, 211, 212 days, 232 days. That comes out okay. 232 days, so that comes out right. Okay. But that's not 232 days from Genesis, because that's actually 232 days from Genesis. It's 232nd day in the calendar, but it's not 232. I wonder if that only affects the year and the Genesis year, because 232, that would actually be it's a 232nd day, certainly, but take away the 1 day and it makes it 231. It makes it actually 230 days from Genesis. So it looks like I have to subtract. It seems like I have to subtract 2 days from Genesis. So if the day lands on the 3rd, let's look at the calendar. If the day lands on the 3rd, that would think that it was 3 days away from Genesis, but in reality, it's 1 day. So it looks like I have to subtract 2. Why do the other ones work then? Let's see. That's gonna throw everything else off. Expected 6, but was 4. So today's the 18th. It should be 6. Why doesn't it apply there? Why doesn't it apply here? but it's probably so many leap years in between. So the test all gets passed, but then the other ones are breaking. And what's amazing is that the code date failed by 2, and the test date of code -6 failed also by 2. The 18 should have been 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And the other one should have been 7. That's kind of interesting. So there's something going on with the current year. But I wonder if it's the calculation of the leap days, leap year days. It could be the leap year days are wrong from 1950. If it's leap year, if year divisible by 4 equals 0. Oh, wait a minute. I'm not calculating the leap years correctly here. Oh, wait a minute. If it's so one way we could get around this is we can say I have a feeling that the leap years are not being counted. Let's see out the leap. Let's see out the leap years, because I have a feeling that the leap years are not being calculated. We'll call it leap years. So I'm counting 18 leap days. Leap year days, 18. From then 21. So the leap days is what must be throwing it off. Leap days. The fact that I'm off by 2 is very suspicious, because I subtract 2 from it. But I gotta subtract those 2 days, because 1950, but what if I'm off on the leap days? The leap year, the year is divisible by 4. So how many leap years are there in between now and 1950? Let's see, 1950 divided by 4. It's not a leap year, so let's try 1952 divided by 4. So 1952, 56, 60, 64, 70, 74, 78, 82, 86, 90, 90, 94, 98, 2000, 2004, 2008, 2008, 2012, 2016, 2020. There's 17 days, but we're getting 18. $2021 is not a leap day, so it shouldn't add it. Am I adding leap year days anywhere else? How am I coming up with 18 when I really should have 17? Am I doing this twice? Why am I counting so many? Why am I going over by one leap days? $18. It's not February, so it's not doing this. How am I coming up with 17? This wouldn't even kick in. What if I just, I have a feeling something is wrong here. So let me comment this out and let me just return true here. Leap days is still 18. Did I count wrong? From 1960 to 2021, there 1950 to 2021, there's 71 years. Divided by 4. There's 17. Did I forget? Is this my bug? this wouldn't matter because I could, there's no years divisible by 100 between now and then. It should still not come out with that. And somehow it's coming out with that. And I'm going from somehow this is wrong. Somehow this is coming out with year mod 100. Put out something here. See out year. Let me print out all the leap years. '52, '56, '60, '64, '68, '72, '76, '80, '84, '88, '92, '96, 2000, 2004, 8, 12, 16, and 20. And how many is that? One, two, three, one, uh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18. There is 18. Okay, so that's not the problem. I mean, I can fix it if I say this is cheating, right? So if days from Genesis, no, if year, I can say if year equals 1950, which is a just a theory, else return days from Genesis, like that. Let's see what it does. And they all passed. So the theory is correct that if it's on the 1950, it's affected by the 2 days, but I can't understand why it's affected on the 1 year and not on the other years. Let's get rid of this. Delete days, we know it's okay. I don't know why it's affected one way and the other way it's not. Those paths, let's pick a random year. And we're gonna have to come back and fix this because something's wrong with this. I don't know why it doesn't, but it's not a factor with all the other years. It shouldn't matter. Let's do another year. Let's look for a calendar. Let's look for 1990 calendar. Let's take one of these. That's not what I meant to do. Let's go with that one. So this is what we want, 1990. Let's test out January 1, 1990. One, 1, 1990, and we expect it to be my calendar. 1990. We expect it to be 1. Let's take a look. We expect it to be 1. For August 20, okay. And now this one failed. Expected 1, but was 3. That gets more interesting. I wonder if these calendars are right. Let's instead of that, let's get a date calculator. I'm not trusting it. the one I want. So let's put 01, 01. That is a Monday. But why are we not? I can't believe we can't get this. 1/1/1990. Do I have the right? It was year, month, day, year, month, day. Year, month, we're passing year, month, day. Get day of week, year, month, day. Get day for year, month, day. Year, month, day. And we are passing them year, month, day. Year, month, day. It's almost like this should work no matter what. But one that's going to fail some tests. See, on this one, date of code failed. And then these passed. But date of code -6 failed. Are my tests wrong? 11/18. Oh, my goodness. It's not 11/18, it's 12/18. That's my big mistake. It's not November, it's December. Okay. Ah, there we go. Yeah, so I had the dates wrong. I was thinking it was November 18. It's actually December. That's why it's like, okay, what's throwing it off? So now if we go back, okay, the code is correct. These could probably use some testing themselves. But, you know, it gets you there. Now, what happens if you wanted to do like earlier dates and stuff like that? Well, the code already works with 1950. What if you wanted to do like instead you switched it to where you did in the 1850 calendar? I don't know all the rules to calendars, so I can't vouch for, say, for example, if we went all the way to 1400 or year 1000, because calendars have changed over time. So I don't really know what would happen in that case. So what if we made our Genesis date be like 1850 is probably not a good day, maybe 1849, because it starts in the middle of it. And I want to start something. So what if we did a different calendar? Maybe 1848. Let's see. We don't want 1848. What if we did? I think they go backwards, don't they? It looks like it went forward. Where we went 1849. So we're going the right direction, 1849. mm, 1849. I tried 1850. I tried 1848. I wanted to land somewhere like here. What if we did 1846? Crap. Well, it's going to move forward. So let's see, 1850, 1890, 1910. What about 1870? Something like that. What we made our Genesis 1870? It's still off. That's not what I expected. Well, crap, it keeps moving them around, not where I want them. What if we said 1869? I should be doing this math instead of playing around with it. I should be doing, let's see. Wow. What about 1868? What about 1867? I keep moving too many days. What about 1866? I just hate to be off. 1866 took me all the way back to that. 1866 would actually work. So let's do 1866 as our Genesis. So what if we did 1866? So 1866, but instead of having -2, so originally we had -2. Would it be -1? Let's see. We clear this. Something's broken. Don't run. No compiler errors. I have to be on the main for it to run. And refresh it. Okay, so they all passed. They all passed at that point, so I think we're good to go. But I don't really know of another way of doing it. Like, what if you wanted to select the year going backwards, and you wanted to go back? Well, there's limits, right, to everything. So it all depends on what you want to do. Um, how far back you got to go to calculate this. This is kind of involved. One thing about the switch, the way it works, notice I didn't put any breaks. And that's so that if whatever month it's in, it'll calculate those days plus the days below it. So if it's in December, it's going to calculate all the days from November all the way to January. All right. So if it's in January, well, I don't need to calculate anything, just the current day that it's in. So it just calculates the current day that it's in there. If it's in December, it'll calculate, November, December, all the way down through January. But if it's in January, it just calculates that one day. And for the current month that it's in, for example, if it's in December, it's calculating days for November, October, September, and so on. And it just keeps following through adding the days, and then it'll add the days for the current month here. But we have to subtract 2 because the reason we have to subtract 2 is because our calendar, if we say days from Genesis, this is 1, and the current date is, for example, January 2nd, it's going to take the 2nd, right? Minus, it's going to be the 2nd, but it's not 2 days from Genesis. It's actually 1 day from Genesis. That's why we have to subtract 1. And so that works. So that's the way you solve this. This could probably be refactored, some of this, to calculate the leap days. This probably can go out and we can calculate the leap days as a separate function. Test that function. This doesn't really need to come out. But in the end, we don't care about all that stuff. We care that this actually works. This is what we care. If these are going to be reusable, then maybe we do want to separate them out so that they work. Now, one thing about this, in this case, because of course, we don't have to worry about this for 100 years, but like the year 2100, any date after the year 2100, or even any year after February 28th, 2100, might not calculate this right. Okay, after like year 2101. Of course, we don't have to worry about that right now because we don't have that, but we would have to worry about it. And I think the only thing we have to do for this to work would be this, because this was never really a problem. It was just a suspicion that I had, because I think I had calculated the years wrong in my head. Ooh, actually, maybe it is a problem. Let's see. Oh, this is a problem. And I think it's this. I think it's this. I don't know how. I do remember this being one of those weird bugs when you do a not equal. So if it's divisible by 100 and maybe like that. They still fail. I wonder why. I gotta be doing something wrong here. Year divisible by. We're already saying if it's divisible by 4. You know what? I wonder if we're calculating, is the year 2000 a leap year? I think that's my problem. I think if it's divisible by 100, then it has to be, if it's divisible by 100, it must not be divisible by 400 or something like that. If we look at the calendars, let's look at the 2000 calendar. Maybe I'm calculating the year 2000. Maybe my logic is wrong in that regards. Yeah, not 2020, 2000. Why did it give me 2020? Let's 2000 calendar. According to this calendar, it is a leap year, but I don't know. I don't know what's, oh. Maybe it's this. It still doesn't like it. I don't know what. Oh, well, yeah, it's going to be wrong because this has to be. This has to be. But it shouldn't matter. It shouldn't jump into that. Definitely something wrong here. this has to be figured out for leap year. Needs more tests. But if we don't worry about those edge cases, it works fine. But I don't know why that other piece doesn't work. Anyway. Well, I hope you enjoyed the video. If you do like it and you haven't subscribed, please go ahead and subscribe button. If you like the video, give it a thumbs up. If you don't like it, give it 2 thumbs down. And it really helps me out. If you have any questions, leave a comment. I'm always willing to help. So just let me know. If you don't like it, let me know why.